Okay, moving on to lesson 4.5, we will be discussing the equation of a line from a table of values. So, if we recap what we've done so far, we have found the equation of a line from a graph back in section 4.3. In section 4.4, we found the equation of a line from a description. Okay, so from a word problem, we were able to make an equation of a line. In section 4.5, all we're going to be given is a table of values, and we are going to calculate the equation of a line from a table of values. All right, so that's we did it in a graph, then we did it in a description, and now we're on to a table of values. Once again, before we start, I'm going to go back over the exact same example that we did in section 4.4 to kind of refresh your memory on finding rate of change and the initial value in Y-intercept from a graph. Okay, that once again is going to be beneficial for us going into today's topic, which is finding the equation from a table of values. Okay, so let's start just as we did last lesson. Let's start by analyzing the graph here. So we have fir tree growth. Okay, so how much a tree is growing. So we're going to be measuring its diameter after so many years. So 10, 20, 30, 40, 50 years. And looking at our scale, we're going by 5 years on the x-axis. Okay, and we're going by 4 inches on the y-axis. So again, you can choose to fill those numbers in. You don't have to, okay? But sometimes it just makes things a little bit more clear when you see those values there. Okay, so let's start with the initial value again. Okay, the initial value, or the y-intercept, is the point that lies right on the y-axis. Remember, just as I mentioned last lesson, the x value is always 0 for the initial value. Okay, so on the x-axis, you're always at 0 for the initial value there. Okay, so if I were to write out the coordinate, it would be 0, 10. Okay, or you can simply write that the y-intercept is 10. Okay, so you can write it as a coordinate, or you can just say that it is 10. Okay, and let's move on to finding the rate of change. Okay, so pick any 2 points. So I will pick, last time I picked this point and this point, so I'll choose different points this time around. So I'll still choose this top point just because it gives me a lot of space to work with. And instead of this middle point, I'll choose this point down here. Okay, so that's step 1, is picking 2 points. Then drawing your right angle triangle is step 2. Okay, so we're going to find the rise. We're going to find the run. Okay, and don't forget that the rise, we are finding the change in the y direction. So from this line to this line, we need to find what that rise was. Okay, so let's look at what this value is here. It looks like it's 14. So I started at 14, and it looks like here that I went up to 30. Okay, so I started at 14 and I went to 30. So how do you calculate that? Okay, by the way, these are both y coordinates. All you do is you take your 30 and you subtract 14. Okay, and it's going to end up being 16, a rise of 16, but I'll wait and let's first calculate the run. Okay, so our run goes from this point here, so from 10 to this point here, 50. Okay, so we went 50 minus 10 to find what that run value actually is. So we get 16 over 40. I'm going to reduce that fraction. So I'm just going to put a little arrow there. Let's reduce that fraction. What value goes into both 16 and 40? Okay, 8 goes into both. Okay, so I'm going to divide the top by 8, the numerator by 8, divide the denominator by 8. 16 divided by 8 is 2, and 40 divided by 8 is 5. So you notice you get the exact same rate of change as we got from lesson 4.4. It's 2 over 5. Okay, 2 over 5. So what that's basically saying is that it grows 2 inches, okay, because the rise is 2 inches for every 5 years. That's basically what that's saying. So 2 inches for every 5 years is what this tree is growing. Okay, so that's just a little recap. Okay, let's move on now again to finding an equation if we're only given a table of values. Okay, so if you were only given this table here, okay, forget the description that is above here, right? Let's forget that for a second. And let's say we were only given, I will erase those lines in a minute. Right now I just want to focus on if we were just given this table of values. How could we find the equation? And remember that the equation is in the form of y equals rate of change times x plus the initial value. Okay, so we're looking for the rate of change and we're looking for the initial value. All right. So let's start with looking at the steps required. I wrote out the steps for us here. So we're going to go through the steps one by one. Okay, but if you can kind of just start to think about things, I mean, how could you find the initial value? Well, remember that the initial value is always the y value that has a corresponding x value of 0. So it's the y value that has the corresponding x value of 0. Okay, so you can probably already see that on our table. And then the rate of change, I'm going to describe down here. Okay, so let's start with that. Let's start by finding the rate of change. So it says, just as we do in a graph, it says pick 2 points in the table of values, exactly like how we do in our graph. That's our first step in our graph, right? So let's erase that circle there. Let's pick 2 points. Okay, I'm just going to pick the first 2. It doesn't matter which points you pick. Okay, so this is a coordinate here, and that's a coordinate there. Okay, so these are our points, 0, 5,000, and then 1,000, 20,000. Okay, so we're done step 1. We picked 2 points. Step 2 says find the rate of change, or the slope, by subtracting the y values from each other. Okay, by subtracting the y values from each other, exactly the way we did up here. If we look at our graph, look how I subtracted 30 minus 14 here, right? I took my two y values here, and I subtracted them. We're going to do the exact same thing here, okay? We are going to take 20,000 and 5,000, and we're going to subtract them. Now you may ask, which one do you subtract from the other? It's always the one below that you write first. So in this case, so I'm going to find the rate of change. I'll just do it right here. Okay, it's going to be equal to the rise over run. We know that. And the rise in this case is going to be the difference between our y values. By the way, C is our y values. Should have mentioned that. And N is our x values. Okay, always the second column in a table is always your y values, and the first column is always your x values. So let's find the rise. And remember what I said, you always write the second number first. Okay, so the number lower down in the column. So we're going to go 20,000 minus 5,000. Okay, then for the run, we're going to subtract the x values here and here. Okay, and again, just like we did here in our graph, we subtracted right? For the run, we subtracted 50 minus 10. So 50 right there minus 10 are two x values, 50 and 10. We subtracted them. Well, we're doing the exact same thing here, except it's going to be 1,000 minus 0. And once again, start with the one with the number that is lower down in the column and subtract the number above it. Okay? So you end up getting 15,000 over 1,000. Okay? And by the way, let's keep following these steps, even though we've worked ahead a little bit. So we've subtracted the corresponding x values, and now we're dividing the y value by the x value, or doing rise divided by run. That's the step we're on right now. If you pulled out your calculators, you would get 15,000 divided by 1,000 is 15. Okay? 15 is our rate of change. Okay, so we just found our slope, or our rate of change. The last thing we need to find is our initial value here. Okay, so let's follow the steps. It says find the initial value in the table. It will be the y value that corresponds with the x value that is 0. So if we look at our table, okay, and I erase, let's just clean this up a little bit. Let's clean that up. It is the y value that corresponds with an x value of 0. So here it is right there, everybody. It is 5,000. That's our initial value just by looking at the table. Okay, so it's always got to have an x value of 0. Okay, so our initial value then is 5,000. Oops. There you go. Okay. I wrote that all out on the lesson sheet. Okay. A couple things to note. So I found the 15 and I found the initial value of 5,000. Okay, so it's already typed out for you. But one thing that I added is, because this was a word problem, and remember I said right now don't worry about the text that's at the top. Okay, well now let's bring that back into play. Okay, and you can see that it already gives us the rate of change, $15 per t-shirt. So down here what I wrote was, I didn't just write 15 because it's a word problem. I need to give it more relevancy. So I don't just say 15, I say that it's $15 per t-shirt. Okay, and that's already been given to me in the description above anyways. Okay, so our final equation is y equals 15 times x plus an initial value of 5,000. Okay, plus an initial value of 5,000. Now, with a real world problem or an application question, you don't really want to leave it as x and y. You want to change it to letters that are more relevant, usually. Okay, you don't have to, but it's good practice to do so. So if we read the question carefully, let's see if we can choose our letters. A t-shirt company's expenses include a startup cost of $5,000 and an additional $15 for every t-shirt they produce. Determine a linear equation from the table shown. Okay, so we are calculating here, and as I said in the previous lesson, it is the exact same question as the previous lesson, so it's definitely relevant with this lesson as well. But usually the questions will be cost and then the number of something. So it's always going to be, 90% of the time, you're going to have C on here, on this side, on the left side of the equal sign, because we're calculating the cost. So cost equals, if I were to write that in words, right, it'd be cost equals $15 times, I used N, okay, because remember what I mentioned the last lesson, that usually you can pick out what that variable should be. Okay, in this case it's n, is look where your rate of change is given to you, so $15. Right after it says per t-shirt or for every t-shirt. So number of t-shirts is a factor here. It's a variable, number of t-shirts that we produce. So that's why I use the letter N. It stands for number of t-shirts. Okay, so N is number of t-shirts produced. Okay, so let's write this out again. So it's cost equals $15 times the number of t-shirts and then plus 5,000. So I'm just writing this out in words. You don't have to do this ever, okay? But I'm just trying to explain to you how this equation here makes perfect sense for this scenario. Because to calculate the cost, you have to take 15 bucks, times it by the number of t-shirts that you produce, okay? And then add your initial value of 5,000. And that's how you will always calculate what your cost is, okay? So this number will always be changing. It's always changing, just like it was in our table, the number of t-shirts, right? You could produce 0 t-shirts, 1,000, 2,000, 3,000. It could be anything, okay? It could be absolutely anything. 1 t-shirt, 2 t-shirts. I mean, it could be anything. So that number is always changing. And when that number changes, so does your cost.